So now we're going to talk about how to solve trigonometric equations. This can be a complicated process, but it's not terribly complicated. There's a couple of things you need to keep in mind. So first, some of the nomenclature. That is what you can expect to see. So you can solve a restricted interval like 0 to 2 pi, right? Or for all values when you're asked to solve a trigonometric equation, okay? You can find exact solutions, that is angles that fall in the unit circle, or approximate solutions, decimals found using a calculator. So when you're doing either one of these, the exact solutions just are limited to what you can find on the unit circle versus the approximate, you're not limited. You can always find the approximate, aka decimals, right? Anytime, even for the exact solutions. However, if it asks for exact solutions, then you should end up with something that's on the unit circles. Just beware of that, okay? There are three trig identities, and I'll say exactly where when we talk about how to solve these get used. But remember, between 0 and 2 pi for things like sine, cosine, and tangent, because if we're talking one of our intervals is 0 to 2 pi, there are two solutions. So whatever you find using the arc sine, arc cosine, or arc tangent, and then for sine, it's pi minus whatever that answer is, cosine 2 pi minus that answer. And for tangent, because its period is pi, you just add pi, which is its period, to find the other answer. Okay, so let's take a look at the process and then we'll do a bunch of examples. Okay, how to solve. First, isolate the trig function. Get the sine, cosine, tangent, whatever by itself. That may involve adding or subtracting values or dividing, whatever you see fit. It's a lot like solving a linear equation, but you're just getting the sine, cosine, or tangent by itself. Then you take the inverse, arc sine, arc cosine, or the tangent inverse, or arc tangent, whatever. Remember, if you're using Desmos, it's easier to type in arc, whatever, arc sine, or cosine first. Please bear in mind, we're going to be doing this in radians unless expressly told otherwise, so make sure that you have whatever you're using to find these values set to radians. Then you find the other solution. So if you've got this, so let's say you've got the sine, right? So you have 2 sine, let's say 3 theta plus 1, right, minus 4 equals, let's see, negative 3, right? So you would add the 4 and then divide by the 2 to get the sine by itself, right? And then you take the arc sine, arc cosine, in this case is arc sine of both sides, which would isolate the angle, which is the 3 theta plus 1, right? And that would give you a value. Now for sine at 1/2 in the domain, that would be what? Pi over 6, right? But there are actually two solutions, meaning for sine, you'd take pi minus that, so pi, which is 6 pi over 6 minus that would be 5 pi over 6. And that would give you the two solutions between 0 and 2 pi. Then you'd add this for both answers. Now, this can be useful even if you're not solving for all solutions. Now the reason it's 2 pi n is because the base period of sine is 2 pi. If it were tangent or cotangent, then you'd add pi n. N is an integer. If it's 0, then it's just this solution. If it's 1, then it's pi over 6 plus 2 pi, which you know to be the same angle. And that can go positive or negative, which means this is covering all the possible solutions. So even if you're solving between 0 and 2 pi, however, it's useful to do this because you want to isolate the angle by, now we want to get theta in this case by itself. So we need to get rid of this 1 and we need to get rid of this 3 theta, right? Now, in this case with how this is written, of course we'd subtract 1, so it would be pi over 6 minus 1. I know this is awkward. And then 5 pi over 6 minus 1. So we would subtract the 1, but only from this. This n is a variable, so these are not like terms. We wouldn't subtract from the 2 pi. But when we divide by 3, right, we divide everything. Because remember, when we're dividing, it doesn't matter if they're like terms. Now, what does this do? Well, if you think way back to graphing sine models, the sine, the period of the sine is equal to 2 pi over the multiple AK3. Please note that that shows up here if you solve correctly with the plus 2 pi n. And what this enables you to do is this is going to be some number. Pi over 6 minus 1 divided by 3 is some number. Then you could add 2 pi over 3 and you should get other answers that would show up, say, between 0 and 2 pi. You may have to add multiple times, or if this ends up being negative, you may have to add several different times to actually get values that fall between 0 and 2 pi. I'll show you what that means here in a little bit, right? But you want to isolate the angle by multiplying and dividing. And please note I'm really doing this to two equations, okay? And then what else? Find the rest of the answers, like I was saying. So between 0 and 2 pi, meaning 2 pi over 3 is a number. We add that, and as long as it falls between 0 and 2 pi, which numerically, by the way, is 0 and about 6.28, right? So if you have approximate answers with their decimals, 6.28 is your stopping point, okay, without going over. So let's take a look at some examples. Now this, we're going to find exact solutions on the interval from 0 to 2 pi. So first, what we've got is what looks like a mess, but it's not. First, I'm going to simplify this a little bit. Negative 15 plus root 3 over all over 3 is the same as saying negative 15 over 3 plus root 3 over 3. Which, negative 15 over 3, hey, that's negative 5. So what I'm doing is I'm simplifying a little bit. And now following my directions, what I'm going to do is I'm going to isolate tangent, that is get the tangent theta by itself by getting rid of this plus, this minus 5 by adding it. And what that gets us, now I'm going to rewrite this using the symmetric property, right? I'm just going to flip this, square root of 3 over 3, right? So where is the tangent equal to the square root of 3 over 3? They want us to find exact solutions, and it turns out this is one. So this is one of those things where we have 1/2 divided by the square root of 3 over 2, right? If you divide that and rationalize it, you're going to get that. So that means that we're looking for something that has a y value of 1/2 and an x coordinate of root 3 over 2, okay? So that means we are looking at pi over 6 is one possibility, right? Remember, when you take the arctan, it's going to be between negative pi over 2 and pi over 2. And so what I'm then going to do is take that, pi over 6, and I'm going to show my work this time, right, and add pi. Why? Because it's tangent and has a period of pi. So pi over 6 plus pi is the same as saying 6 pi over 6. So that's 7 pi over 6. Those are our two solutions. Now, in this case, I would normally add my plus 2 pi n, but I want all the exact solutions between 0 and 2 pi. If I were to add pi, I'd get this again. If I add pi again, then I get 13 pi over 6, which is more than 2 pi. So it turns out in this instance, theta is pi over 6 or 7 pi over 6, and those are the only solutions. Okay, that's it. So the next one, same idea. If we look here, notice that this is we're taking the sign of this whole thing. So we're going to deal with that later, okay? So what I'm first going to do is get rid of this 2/5 by multiplying by 5/2. There's nothing to simplify like there was before, no weird fraction. So now I get the square root of 2 over 2 equals the sine of theta plus pi over 4. Now I'm going to get rid of the sine by taking the arc sine. Remember, that's the same as, because these are exact solutions, which means square root of 2 over 2 does show up, right, in that interval. One angle gets us a sine or y value of square root of 2 over 2. Why, that would be pi over 4, right? Now, what is the other value that gets that? Now, I'm going to go ahead and I'm going to add the period in here, 2 pi n, right, in case I need it. And then here, what's the other solution? So remember, that's where we have the sine of theta, or sine of x, equals pi minus. So I'm going to do pi minus pi over 4. For tangent, it was pi plus. For sine, it's pi minus. And for cosine, it's 2 pi minus. Pi over 4 minus, pi minus pi over 4 is 3 pi over 4, right? 4/4 minus 1/4 plus 2 pi n. Now, I've not quite got theta by itself, so I'm going to go ahead and boldly get rid of this pi over 4 by subtracting it. So when I subtract it, it's only going to affect the pi over 4. Back that up. The pi over 4 and the 3 pi over 4. like I said earlier, this is being multiplied by n, so they're not like terms. In other words, when you add or subtract like this is a horizontal shift. Does it affect the period? And the answer is no. So when I subtract pi over 4 from pi over 4, I get 0. When I take 3 pi over 4, I get, and subtract 3 pi over 4 and subtract pi over 4, I get 2 pi over 4, aka pi over 2. In other words, I simplified it. Okay, there's my solution. Now I know the period is plus 2 pi n, so if I added 2 pi, that would fall. Oh, I'm not including 2 pi. Here, and if I add the 2 pi. So what I'm trying to get at is these are the only solutions. In this case, when you're asked to find solutions on an interval, the plus 2 pi n stuff comes in handy when the period has been changed. So really, if you don't have a period change, that is no multiple in front of the theta or x or whatever, then you don't have to worry about it. Hey, look at that. Our final example has a period shift. Okay, so brace yourselves here. I'm going to give you a couple of things at once. Negative 15 over 3 is negative 5. Negative root 3 over 3 is negative root 3 over 3, right? So I'm just simplifying this. Negative 5 plus 2/3 cosine. Now I'm copying a whole bunch of stuff. Negative 4 theta plus pi over 6. Okay, so I'm going to add 5 to both sides, and those are going to cancel. I'm also going to multiply by 3/2. So what happens? I'm going to get negative root 3 over 2 equals, I'm going to put this over on this side, cosine negative 4 theta plus pi over 6, right? So now I'm going to take the arc cosine, and that's going to get the angle, which is the negative 4 theta plus pi over 6 all by itself, and that's going to give you my two answers. So when is the cosine negative root 3 over 2? Well, when the x-coordinate is negative root 3 over 2, which when you look at the unit circle is 5 pi over 6, right? That is one of the solutions, plus 2 pi n, and this is going to be very important. Next, I'm going to do the exact same thing with what? Well, because it's cosine, I'm going to have to do 2 pi minus that solution, 5 pi over 6. 2 pi, that's the same as saying 12 pi over 6, so 12 minus 5 is 7 pi over 6, which is my other answer. If you check the unit circle, you'll find that that's true, right? So now I've got these two situations, and so what I'm going to have to do is get theta fully by itself. And I'll do this in steps, just to be generous. So I'm going to subtract pi over 6 from both sides, and it's just going to affect these two, which is 4 pi over 6, or 2 pi over 3, right? Plus 2 pi n. So remember, when I subtract the pi over 6, let's do that in this color, subtract pi over 6, subtract pi over 6 just here, and just here. 5 minus 1 is 4. 4 over 6 can be reduced. 7 minus 1 is 6. 6 over 6 is just pi, right? Plus 2 pi n, okay? But now I have to divide everything, and when I say everything, by negative 4, which means all of this is divided by negative 4, and all of this, because this is really two equations, right? 2 pi divided by 3 divided by negative 4 is negative 2 pi divided by 12. I'm going to fix that in just a sec. Plus 2 over negative 4. Now it turns out the negative doesn't make a difference because n could be positive or negative, so you can really kind of ignore the negative for this part. 2 over 4 is the same as pi over 2 n, which is the period of this, so that makes sense. And then, of course, negative pi over 4 plus pi over 2 n, okay? Now this is really the same as saying pi over 6 plus pi over 2n, and then, sorry, negative pi over 6, negative pi over 4 plus pi over 2n. Okay, now you may be wondering why in the heck I did all that. Well, it turns out there is actually a reason, and the reason is I have two values here that aren't really, well, frankly, just aren't really where they're supposed to be, are they? Meaning this is supposed to be a solution between 0 and 2 pi. So what I have to do is somehow get these between there. So there's a couple different options. First off, remember if you're finding a coterminal angle, could you just add 2 pi to this value and come up with what you want? The answer is, of course, yes. All right. The other option, but let's do that to start with. So that means negative pi over 6 rather, plus 2 pi or 12 pi would be 11 pi over 6, right? Plus, right? 11 pi over 6. Now I'm going to do something fancy here. I'm going to make this 3 pi over 6 because I want a common denominator, okay? Now, what's next? I'm going to go ahead and take negative pi over 4, add 2 pi. So after I add the 2 pi, so I'm adding 2 pi, and in this case that's 12 pi over 6. And here I'm adding 2 pi, which in this case is 8 pi over 4, right? Common denominator stuff. Negative, so that's 7 pi over 4, plus, well, I'm going to take this pi over 2 and make it something over 4, so I have to double it, so it's 2 pi n. All right, this is still not quite there, but we do have a couple of our solutions. So when we're looking at theta, let's scroll down a little bit here. When we're looking at theta, theta is going to equal a bunch of numbers, one of which is going to be 11 pi over 6. Now, if I were to add 3 pi over 6, I'd get 14 pi over 6, which is more than 2, so that's not a possibility. But remember, I can subtract, so I'm going to go ahead and subtract, which means I'd get, well, 11 minus 3 is 8 pi over 6. But I'm going to have to reduce that, aren't I? That sucks. But here's a reason to keep it like this. Then I can subtract a 3 again, and then I get 5 pi over 6. Could I keep going? Yes. 2 pi over 6, right? That gives me 4 solutions just from that. Now, are some of these reducible? So what I did is I took this first one and I couldn't add because it got me 14, so I subtracted it until, well, if I kept subtracting, this would be negative and that wouldn't count. So now, so that's what I got in blue. I'm going to go ahead and we'll do the red version here. I'm going to do the same thing. So I have 7 pi over 4. If I add 2 pi, it's going to go over. Problem. So what do? Well, I subtract. Well, 7 minus 2 is 5 pi over 4. So you can see why it's useful to have that common denominator. 3 pi over 4. And then 7, and subtract pi over 4. Sorry, 2 pi over 4 again. We get pi over 4. Okay? Now I would expect you to simplify these. So in the end, now 11 over 6 can't be simplified. 8 pi over 6 is 4 pi over 3. Divide both by 2. 5 pi over 6, can't do it. 2 pi over 6 is really pi over 6. 7 pi over 4. 5 pi over 4. 3 pi over 4. And pi over 4. So as you can see, you get 1, 2, 3, 4, 5, 6, 7, 8 different values that work between 0 and 2 pi. Frankly, solving between 0 and 2 pi is a pain. Okay, so you're hoping that they actually solve it for all approximate solutions. So here's what this would look like. You're going to love this. Negative 10 divided by 2, that's negative 5. Negative root 3 over 2. Negative 5 plus cosine theta, right? So first I'm going to add 5 to both sides. So I'm going to get cosine theta equals negative root 3 over 2. Now, yeah, technically we could write this in terms of pi, but it wants approximate, so I'm just going to go ahead and run the numbers. So I run this through Desmos, and what do I get? I get 2.617. That is, I took the arc cosine of negative root 3 over 2. Don't forget your plus 2 pi n, right? And then I'm going to take 2 pi minus this solution, right? Which, by the way, equals 3.665, right? Plus 2 pi n. So these two things are the solutions, and I'm done. It doesn't matter if these are positive or negative in the end. I'm done. So let's try this one. Same idea. Isolate the exponential. Take the arctan. When you take the arctan, you get 0.360, but plus, oh, I'm sorry, you don't get that. I'm skipping a step ahead. You actually get negative 1.441 and because it's tangent, plus pi n. So now I'm going to divide everything by -4. Now remember, this is tangent, right? Meaning the other second solution would be at plus pi, but I've already got it covered because I'm already adding the pi n. So when I divide this out, I get 0.360 plus, now please note, this negative, it doesn't matter because n could be positive or negative, right? Pi over 4 n. And that is your final solution. Remember, because we're talking about tangent, we only need to worry about one solution because I'm already adding the pi n, which is the over tangent theta equals tangent pi plus theta. Well, I've already done that, so why do it twice? Okay. So, a couple more examples. Finding all exact or approximate solutions and when are possible. So in this case, we can actually do the same thing, and we'll just do a couple of these. We don't need to do all of them. So what I'm going to do is get rid of this -2/5 by multiplying by -5/2. There was nothing being added or subtracted, right? Which means this will cancel and negative, so I get √2/2 equals sine theta. Well, it turns out I can get an exact value. So when possible, can I? Yeah, I get pi over 4, right? And the other one would be, the other answer, right, would be, because this is sine, it would be pi minus pi over 4, which is 3 pi over 4, plus 2 pi n plus 2 pi n. Done. There's nothing to add or subtract or divide, so we're done. So tangent, I want to divide by 2, which means I'm going to get -√3 equals the tangent of theta plus pi, right? Take the arctan. Where is the tangent negative? Well, it's going to be at a negative angle. Specifically, what angle? Well, it means it's going to be the square root of 3 over 2. So I believe this is negative pi over 3. Let me just double check some stuff here. Negative pi over 3. And then that gets the theta plus pi by itself. And because it's tangent, I'm adding pi in because that's its base period. I don't need to find the second answer like I did over here because I'm already adding the pi. So then the last step is to get rid of the pi. Pi over 3 minus pi. Remember, it's not going to affect the period because adding or subtracting won't affect the period. Pi over 3 minus pi is -4 pi over 3. Remember, negative pi over 3 minus pi would be 3 pi over 3. That's how I ended up with a -4 pi over 3. Just because it's negative doesn't matter. I'm adding pi in, that covers all the bases, okay? So let's do the last one just for argument's sake so we can see what that looks like, because this looks like a complicated mess. But because we're finding approximate solutions, it's not that bad. So first, let's do a little bit of simplification. Right? So what does that get us? Well, the 5s are going to cancel because I'm going to subtract them. I'm going to multiply by a -2 over 1. So I'm going to get cosine of 4 theta plus 5 pi over 6 equaling √2 over 4. That's going to cancel, so I'm going to get -√2 over 2. Where's the cosine negative? Well, it's going to be between pi over 2 and pi. As a matter of fact, where it's negative, it's going to be at 3 pi over 4 when we take the arc cosine. So this is another example where we can get the exact value. And because it's cosine, so now I got 4 theta plus 5 pi over 6. It's going to be plus 2 pi n, right? In fact, we know this is going to be plus 2 pi n. We need to take 3 pi over 4. We need to do 2 pi minus 3 pi over 4. Well, that's really 8 pi over 4. So that's 5 pi over 4 is the other answer. Now this is where the fun begins. I need to get rid of the 5 pi over 6, which means I need a common denominator between these two, and then I need to divide both sides by 4. So the common denominator for 6 and 4, sadly, is, well, it's not actually that sad, is 12. So this is really 10 pi over 12, right? And this is really what? 9 pi over 12. And this is really 15 pi over 12, right? Multiply by 3, multiply by 2. So that way when I subtract this, I'm going to take 9 pi over 12 minus 10 pi over 12, which is negative pi over 12, plus 2 pi n. And remember, I still haven't gotten rid of the 4. 15 pi over 12 minus 5 pi over 12 is going to be, 15 pi over 12 minus 10 pi over 12, get that right, is going to be 5 pi over 12. Okay? It's okay that this is negative, just leave it alone. Almost there. Last step, divide by 4. What do we divide by 4? Everything. So that means theta is going to equal negative pi over 12 divided by negative pi divided by 12 divided by 4 is negative pi over 48 plus 2 over 4 is 1/2, or pi over 2n. And because the period has been modified and the period is plus 2 pi n, we're going to get that. And when we take 5 pi over divided by 12 divided by 4, we get that over 48. So it turns out finding all solutions is a lot easier than finding between 0 and 2 pi, but there it is. Hopefully this has been helpful.